Welcome class to this college algebra video. This is the video solution number 3, and I'm going to start off by breaking down this graph. So to start off, we're given a function and told to explain these different parts and to draw out the graph. So to start off, we're told to find the zeros, the relative maxima, the relative minima, and do some stuff with figuring out our end behavior. Now, I'm going to start off with breaking down the graph and talking about the end behavior. Once all of that is done, I'm going to use my calculator to break down how to find the zeros, the relative maxima, and the relative minima. I'm going to use some special software to do that, so you'll see how on a calculator it can be done instead of me just telling you I found it. So to start off, here's the graph. For now, you're just going to have to trust that these are all the right points until I go ahead and break down that on the graphing calculator software. But for now, let's talk about the end behavior. As x begins to approach infinity, so that means as x becomes more positive in an infinite way this way, what is happening to our graph? What is happening to our f of x? So as we're getting more positively infinite, our graph is going up, and it's becoming more positively infinite. So as x approaches infinity, f of x is also approaching infinity. So that's why it's the positive infinity over here instead of negative infinity. And as our x approaches negative infinity, so as it goes more this way, it is becoming more negative. See how as we go this way, it's going down and becoming more and more negative instead of more and more positive. So we display that by saying that it is approaching negative infinity because it's going more and more this way and it's going down. So that is some of the end behavior, and to point out, just for now, I'm also going to break this down in the software, but here are our zeros and our relative maxima and our relative minima. So this is our graph. Now I'm going to go ahead and break it down for you on that software. Hey there, class. Welcome to the video solution. This is a software that I'm using that projects my calculator onto my computer screen. So that way I can show you various different elements and show you exactly how you would go about doing this on your calculator. Instead of just trying to show you my calculator or just say it happened, I thought I would download some software and show you how it's done exactly. So, to start off, the question asks us to find all of our zeros. And so to do that, we click on our graph and we have to go to the Analyze Graph section and go to our zeros. So then we have to select the left and the right sides, and then we get our zero. So here's one of our zeros. And then we can do that again with each of the different zeros. Now, just to reiterate, a zero is each time a graph crosses this x-axis. So in here there's 1, 2, and then there's another one right here that we're going to find. When we analyze our graph, go to our zeros, now we have our next zero. So now we have all 3 of our zeros, and that was our first step in finding them. Now, the next question asks, and I'm going to delete this text so I can show you better, but the next question asks for us to find the relative maxima. Now, that is wherever relatively there is a high peak, a peak where you would have to move up to get to. So that is right around here. And to find exactly where that is on the graph, we have to analyze our graph, go to our maximum, go to the left and the right bound parts, and now we found our maximum, which is -5, 7, and it puts a point there to show us where exactly it is. And then now we have to find our relative minima. So that is the lowest point here, relatively. Obviously, it's not the one going all the way down to negative infinity, but it's the relative one. So to find that, we have to analyze our graph, go to our minimum, go to the left and the right bound, and then here is our minimum. And that is all the stuff that is asked for in the question. So we've found our zeros, we found our relative maximum, and we found our relative minima. I hope that it helped having this on a actual calculator program and that you were able to see how everything is done with clicking the buttons and figuring out where everything is. So that way, when you do it on your calculator, you can see exactly where it came from. Now, back on to me demonstrating the next problem. Welcome, class, to our third problem of this math video adventure here. And I would say that this is the most complicated one out of our three problems because it's given a complicated topic like inverses, which is hard to understand and get a good grasp of what's happening. But in this, we're supposed to use compositions to figure out how we know that two things are inverses of each other. Now, I put some notes here to help us understand where we're going in this. So first, if f of g of x is equal to x and g of f of x is equal to x, then both functions have to be inverses of each other. So in our previous problem, we talked about how to use some compositions to get certain things. So we're going to be taking those same skills and translating it into how to use them in getting our inverses and figuring out if these two are inverses of each other, which in the problem, it's given that they are inverses, but whatever. So moving on to the math portion of it, this is saying, just reiterating what our f of x and our g of x are, so that way we can use them in our problem. But the first thing that we have to do is we have to solve f of g of x. So to do that here, we've gone ahead and put it together. So we took our g of x and we put it into every x of the f of x function. So we get this beautiful piece right here. And then we go ahead and multiply this part out and we get this right here. And then we subtract the 9 and then we get our x. So this is good news. We're going on ahead. We know that this is x. So that's a really good sign. And then we do the same thing similarly with our g of f of x function. And we put it all together. We put our section right here and we put our section right here and we take this part and put it into our x right there. And then working out the math, we multiply this with this and get this and then subtract that term and then we get x. Yay! So now that these are both x terms, we can decide that since this is equal to x and this is equal to x, that means that both of these functions have to be inverses of each other because of the laws of math and how that this all works. So that was the video solution. Hope you enjoyed and hoped that all the use of technology was helpful in your aiding of understanding how functions and graphing and all these other things work. Thank you. Hope you enjoyed.